Welcome to railroading time. This time we've arrived at the turn of the 19th century. Engineers are developing railway technology faster than most people today build flat pack furniture. And just like those instructions, early rail technology had some issues. Rails broke, locomotives slipped, and steam locomotives loved to explode, generally at the worst possible moments, usually near passengers, livestock, or journalists eager to cause moral panic. But amidst this chaos, a bold group of inventors asked a question no one else dared to ask. What if we powered the trains not with locomotives, but with air in giant tubes? Welcome to the story of the atmospheric railways, a technology that was ingenious, ambitious, and catastrophically sabotaged by weather, rats, and leather. Yeah, that's right, leather. So grab a cup of tea or a vacuum pump, things are about to get very strange. Imagine it's the early 1800s. Steam locomotives are in their infancy. Early ones like the one built by Richard Trevithick in 1804 was so heavy that it snapped the cast iron rails like breadsticks. So engineers had to start thinking creatively about alternatives. Maybe too creatively at times. Some proposed cables. One of the contenders in the Liverpool to Manchester line was literally 1 horsepower. It was a horse on a treadmill. Henry Pincus proposed sealing a slot with a tube using a rope that later portrays him by stretching dramatically. It's a recurring theme. Early railways were basically an engineering group project where everyone had different ideas. Some were good, some were bad, others were terrible. But the atmospheric railway concept actually made sense in theory. It used stationary engines. These have been around for a long time, since about half a century. And it could create suction in a long pipe. Air against the piston inside the pipe will pull the carriage along, or even push it from behind the carriage. There's no heavy locomotive needed. Nothing to explode. Nothing to snap the rails. There's no smoke, no slipping. Like I say, there's fewer explosions. This is always a bonus. It was like the 19th century inventor saying today, why carry the battery in the car where you can just plug yourself into the road? Our story begins in 1799 with George Medhurst, the man who looked at cast iron pipes and thought, what if we put goods in here and moved them along using air? Later on, he had another thought in 1812. Perhaps we could put people in there as well. Presumably he had other thoughts between that time, but these are the two we're worried about. But he never patented anything. Nothing he suggested ever got built. But his ideas were the start of the atmospheric system that was to come. He was basically a hipster. He was cool before atmospheric pipes were cool. First person to actually make something of the atmospheric railways, or using air to push the train along, was John Vallance in 1824. He had this idea of putting the entire train inside an enormous tube and then blast them through like a piston. He built up a 6-foot diameter model in his home in Brighton, used rails at the lower part of the tube so the carriage to run on, and then bearskin around the outside to seal the tube and the carriage. I don't think he had anything against bears, but no, obviously worked. Then either end doors would open to be able to slow the train down or allow it to stop. It worked, but there was only one flaw. Who on earth would want to be transported in a train that's surrounded by a metal tube? Shocking, I know, but who would? Between the cost and the claustrophobia, Valance's dream died quietly. But the idea of using air to push trains along pushed on. Remember we talked about Henry Pincus at the beginning of the video? He enters the chat around about 1835 with a better idea. Let's keep the passengers outside the tube and place only a piston inside the tube. Smart thinking. Less smart. He sealed the top of the tube with the rope to stop air getting out. This was to prove very fatal for him. He built a demonstration line along the Kensington Canal, and to keep the pressure in, like we said, he came up with a system of rollers that would move the rope aside as the piston went through and then reseal it afterwards. But the rope stretched. Everything failed, air leaked, investors vanished, and interest in the National Pneumatic Railway Association was lost like the air from the tubes when the rope stretched. But Pincus unknowingly created the basic layout that many future systems would copy. We'll have a narrow tube with a slot running along the top so that the piston can come through, and a connection to the rail vehicle above. A good idea, just needed a bit better execution. The next people in the story were two brothers, shipbuilders and engineers, Jacob and Joseph Samander. They worked with Simon Clegg, who was a gas fitter. They built the first operational atmospheric railway, leasing a mile of track from the West London Railway at Wormholt Scrubs, as it was then, but now Wormwood Scrubs, in 1840. The system was surprisingly advanced. It had a continuous cast iron tube laid between the rails. There was a hinged leather flap, got rid of the rope because that obviously didn't work, and that ran along the top, which would seal it and would move away as the piston rolled along, it would bring it out. And there was a piston on the carriage at the front which provided the movement. Stationary engines would pump air out ahead, creating a vacuum, which presumably meant the train would then use gravity to go back down the hill afterwards. They used a wax and tallow mixture to seal the slot after every train, coated onto the leather, which keep the seal in. Then a heater under the carriage would melt it, which would allow it to raise, and then it would cool down afterwards. It had a metal cover on the leather. This would keep the weather out to stop the leather from rotting. Big point for later on. And it worked beautifully at first. The trains reached 50 miles an hour. Crowds cheered. Newspapers went for it. No locomotives were exploding. This was brilliant. Engineers from across Europe visited. The Samander system became the blueprint for atmospheric railways from Ireland to France. In 1843, the Dublin and Kingston Railway wanted to extend into very hilly territory. Steam engines of the era, although they could no longer brake in the rails, they were still bad at hills. Very bad. A lot of them could barely pull themselves up a hill, let alone a train as well. Atmosphere to the rescue. It didn't have a loco to worry about. After seeing the Samander line in London, their engineer proposed the same sort of system. There was a couple of modifications though. He used a bigger diameter pipe, a 15-inch pipe. One big pumping station which would create the needed vacuum in 2 minutes. The train was pushed manually into position, ready to get it all set up, and then the piston was sealed. It was held on the brakes until the vacuum was enough to be released, and it shot up a 1 in 57 gradient like a dart along a blowpipe. On the first test run, it averaged 30 miles an hour up a slope. This was unheard of by any other method of transport. Descents were even easier. They simply let it roll down using gravity like a Victorian roller coaster. Again, the people loved it. Engineers visited across Europe. People like Robert Stevenson, Sir William Cubitt and Isambard Kingdom Brunel. The system lasted 10 years, making it one of the few atmospheric lines that didn't die instantly. Eventually it was replaced by steam, but not because it failed, just because steam got better. If the story stopped there, atmospheric railways would be a triumph. Unfortunately, it didn't stop there. 2 years later, the French got involved in the story. The French government, impressed by the Dalkeny Railway, decided to build their own atmospheric system up a steep slope to the palace town of Saint-Germain. A 25-inch tube this time, had even bigger pumps and there was leather flaps all around using the same system as the Samandas. It worked technically. Speeds were good, the service was popular, but again, as steam engines improved, the atmospheric system became unnecessary, and in 1860 they quietly replaced it. Again, it's a good system, just the wrong century by the looks of it. Unfortunately, this is where things started going wrong with the atmospheric railways. They started getting very popular. The London and Croydon Railway started using it themselves. They had a big hill they needed to get up there to relieve congestion. So in 1846 they commissioned an atmospheric railway. As they're having to share a line with the London, Brighton and South Coast Railway, who wished to run expresses from the South Coast around Brighton to London, and the Croydon Rail proposed to build a third line from the New Cross to Dartmouth Arms for their stopping trains. Their engineer, William Cubitt, thought, I've just seen a railway that works. Atmospheric railways, what could go wrong? In fact, a few things went wrong. Here's a summary. Remember that weather cover I was talking about, the metal flap over the top of the metal plate over the leather flap? Didn't bother with that. So, it stiffened in the heat. Then it stiffened in the cold, which made it fragile. And it tore in wet weather because it got so wet. And because they had full access to it, and remember they coated the leather with tallow to keep it supple and so on to help to keep that seal, that attracted rats. Yeah, rats. Lots of rats. In fact, it was said that each morning when they did the first pump out, it created a rat tornado out the end of the pipe. This was that was really where things started going wrong. And meanwhile, the stationary engines they bought kept breaking them. 2 of them broke on the opening day. Vacuum leaks became constant because the leather flap kept ripping, stiffening, tearing, getting eaten by rats. And trains started to stall on the inclines due to debris that was now being allowed in the vacuum tube. Apparently one of them was a lady's handkerchief. Hey. And the newspapers mocked the railway daily. By 1847, just 1 year after it was built, the directors decided it was time to close it. The entire atmospheric pipe was ripped off. It was chaos, beautiful Victorian chaos. This is where we come to the big one. Probably the most well-known example of atmospheric railways being used, the South Devon Railway. Isambard Kingdom Brunel, when we saw it again in Ireland. He decided for the South Devon Railway, which is a very hilly area, that the atmospheric railways would be the answer to his dreams. So in May 1841, a broad gauge line had started from London and working with the Great Western Railway and the Bristol to Exeter, and managed to reach Exeter. Seeing the possibilities it would bring, the great and the good of Devon, they wanted a link to Plymouth. The problem was the Devonian countryside was extremely hilly and has been suggested before would be impossible for steam locomotives of the time to be able to navigate the route on their own, let alone with a train attached. After seeing the Dalkeir Railway, Brunel saw the atmospheric railways as a solution to his problems. Despite the reputation it has now, credit must be given to Brunel and his team in solving some of the problems of having tubes running between the rails. For example, at level crossings, where the road surface must be the same level and protection is needed for the flap of carts travelling over the top. This was solved by using a metal hinge flap over the top of the pipe, which could be raised by using steam to lift as a passenger train went through. This coincidentally also acted as a warning to road users, like a little roadblock. At the stations, an auxiliary traction pipe was used beside the track so it could navigate around the points. This was connected to the carriage via a rope. But there were problems, as there always are. The pipes were miscast, so they warped, meaning it wasn't a smooth run. This affected the train's journey and had to keep getting re-railed and then dragged away from being stuck. Brunel himself underestimated exactly how much power he would need to move it from point A to point B, and he didn't put enough stationary engines along the line. The weather cover, recurring theme, didn't bother installing that. So the leather cracked when it froze, it soaked when it was wet, it tore and demanded constant maintenance. And the tallow attracted, guess what? More rats. Lots of it. Repairs became expensive, really expensive. For a brief period from 1847 to 1848, trains did run atmospherically. Speeds reached 64 miles an hour downhill with light trains, so performance was promising. But maintaining that flat became a financial black hole. Sections had to be replaced constantly. Samander, who was brought in as an advisor on it, argued with Brunel, and Brunel argued with Samander constantly. Shareholders rioted, politely of course, because they are Victorian. And in September 1848, the atmospheric dream officially died. Brunel, with a heavy sigh, enough to create his own vacuum, gave up. After the 1840s atmospheric implosion, the idea slept for a while. It never fully died though. In 1864, there was a demonstration line put under Crystal Palace. Alfred Beach built a pneumatic subway beneath Broadway in 1870, complete with chandeliers and fountain, because why not? It amazed New Yorkers, but it was immediately shut down due to the same problems. Victorian bureaucracy, consistent for 200 years. However, despite all these problems, the idea of using air to move a train along is still not dead. Shockingly, the idea came back in the late 20th century, and it's worked. Brazil's aeromobile system uses a modern piston plate and a sealed duct, modern metals helping it out. It's got many remote air pumps all the way down the line, keeping that air pressure constant, and it has got lightweight driverless cars, again modern alloys helping it move along. And thanks to rubber coming along and vulcanization process, the flaps are no longer being eaten by rats. It survived. And you'll find them today, actually. You'll find them in Jakarta. That was the first system to be installed at Porto Alegre Airport and in Brazil's research centres, and there's future projects planned around the world. So yes, the atmospheric railways do live on, and they're growing strong. Just with fewer rats and much better materials. So the atmospheric railways themselves, they were technically brilliant. They had the right idea, but steam obviously got better, which replaced it all because there was problems that needed to be overcome. They're environmentally clean. We didn't need as much smoke and coal being burnt to move them along. They were quiet, fast. They're frequently sabotaged by the weather and rodents, which we know. But maybe they were just ahead of their time, as we know that they're coming out now and they're working well. In another century, it could have been revolutionised transport. Maybe it's a thought as trains go into the future. Use a lot less of it. But in 1840, the world simply wasn't ready for the giant vacuum-powered trains run by delicate strips of cow skin. So next time you see a high-speed train, an airport people mover, or even a pneumatic tube in a bank, remember, there was once a moment in history when railways nearly ran on suction, and honestly, it almost worked. So if you enjoyed this look at a more unusual form of transport for the railways, please like and subscribe this video and follow on more as we delve deeper into the fascinating history of railways in Britain and the world. Until next time.